differentiation, which is basically about population growth and how certain factors affect that population growth. So there's this one guy named Thomas Malthus, who studied population, and he said that after a certain point, population growth would stop, and there would be no more population growth. So we can sort of graph this according to this equation where n is the current population, and then we're trying to solve for n of t, which is the total population with this equation. So we can create a differential equation, dn over dt equals Rn, where R is a constant and n is the current population. And then we solve, we separate the variables to solve for dn here, because this is unknown, by doing dn 1 over n equals R dt. And then we integrate both sides, and we get natural log of n, but we have to do absolute value because natural logs can only be on the positive, or can only take in positive x values, and then this would be R of t plus c, the constant. Okay, and then now we go and we have to solve for, scratch that out, we're not solving for c anymore. We just want to get the equation with the c, because we don't have any variables to plug in or any known values for any of the variables. So we're just solving for n of t at the moment. So we could do that by putting everything to the power of e. So e to the power of natural log absolute value of n equals e to the power of RT times e to the power of c. And then e to the power of c is also just c times e to the RT, and then the e to the power of a natural log is just the n. And then between these two steps, we can just assume that n is greater than 0, so we can just get rid of the absolute value, and then we end up with this equation. And so this equation here, if you graph it out, you get something like this, which, according to Thomas Malthus, doesn't really accurately portray population growth, because he said that it eventually caps out at a point. So, as we will go over in the next video, the actual graph of a population curve is different. Our actual graph of a population is different and actually ends up curving down sort of to the limit and not passing the limit. So something like that. But the end, wait, what was it called? End behavior.